Introduction. The use of Geographic Information System and remote sensing to detect land use changes has made land use mapping a valuable tool for selecting appropriate areas for urban, agricultural, and industrial development in a city. GIS offers a suitable framework for collecting, updating, analyzing, and retrieving spatial data in the field. The use of GIS software in Malaysia's rubber land use changes is an innovative tool that helps locate and track areas used for rubber plantations. Problems faced before innovation. Objectives of innovation. To analyze land use and land cover changes using GIS. To identify changes in land use for rubber plantation in Malaysia based on different years. To assist the land use development planning in Malaysia. Steps for PRE processing image. Let's try to produce a land use changes map for Alor Gajah area.
First, open the desktop file of the ArcGIS Pro version 3.0 software. To begin a new project in a new project file, click Start without a template. There will be a new project file added to the desktop. After that, insert a new Malaysian map and it will show up on the desktop. This region, Alor Gajah, Malacca, Malaysia, is the focus of investigation. After that, select Add Data from the menu under the Map button. In the Add Data appearance, select the entire raster dataset, which is in .img format. The raw data of numerous Landsat 8/9 OLI photos will eventually show on the screen after a little delay. Click the View button, then Geoprocessing Tools, then Data Management Tools, then Composite Bands. By combining different raster datasets, Composite Bands creates a single one. Insert Band 1 to 7 under Geoprocessing Composite Bands Tools. Utilize the Landsat 8/9 pictures as the input raster and look for the output in the output raster file. Composite Band is used to create the image, which appears on the screen. Click Geoprocessing Tools in the View button and then Spatial Analyst Tools, then select Extract by Mask. The Extract by Mask tool extracts the raster cells that match the areas specified by a mask. Insert the input raster and the input raster or feature mask data into the Extract by Mask tool, then find the output raster folder. Alor Gajah's image has now been extracted and displayed on the screen. Go to Image Classification in the Imagery button's Classification Wizard menu. In the Training Samples Manager, add additional classes for forests, built-up areas, agriculture, water bodies, open spaces, vegetation, and clouds. Create a few samples on top of the image in accordance with the classes established using the polygon and circle tools. Save the created training samples in the Output Location folder for storage. Choose Supervised as the classification method and Pixel-based as the classification type in the Image Classification Wizard. Save the output in the folder designated for outputs. Next, select Maximum Likelihood as the classifier. The performance of this classifier is predicated on the assumptions that Bayes' theorem and the cells in each class sample in the multidimensional space are normally distributed. The screen displays the classified raster preview. After that, use the Export Raster tools to export the classified raster. The Content menu then displayed the classified Alor Gajah 2015. Repeat the technique using a different satellite image from a different year. Create the final output of this product, Land Use Map of Alor Gajah in year 2015, in Layout View. To compare and visualize the land use changes, repeat the processes to create the Land Use Map of Alor Gajah in year 2021.
This thematic map displays the land use in Rembo District in 2021, created using GIS. Pink color represents rubber land, light green for oil palm land, and other colors for forest, open land, development, cloud, and water areas. Impact of innovation.